Captain R.K. Skerritt, USS John Paul Jones. Sir, I am writing you, sir, to appraise you of what is undoubtedly the most remarkable event of my assignment to Washington after serving over 2 years under you on the John Paul Jones. An event, sir, which I think you will also be interested in. It is in my present position as testing officer at the Navy Yard that I have come across a most unusual and extraordinary weapon called the Gatling. I have found this Gatling so impressive, even astounding of performance, that, please do not think me crazy when I say this, that I can envision the day when every Navy craft will have a Gatling aboard.
Presently in service on U.S. Navy and Marine aircraft are 3 basic Gatling guns: the 6-barrel 20mm M61A1 Vulcan, the 3-barrel 20mm M197 lightweight Vulcan, and the 6-barrel 7.62mm Gao 2BA, better known as the minigun. Basic design, engineering, and logistics support for these weapons are provided by the Pacific Missile Test Center, Point Mugu, California, the Navy Cognizant Field Activity for Aircraft Gun Systems. Today's Vulcans and miniguns are marvels of high-speed material handling. Gun firing rates of up to 7,200 shots per minute can be tailored to any application. Since the firing operation of these guns is based on simple rotary motion, reliabilities far surpass any other conventional machine gun, making the Vulcans and minigun the most reliable high-rate-of-fire weapons in the world. Operation of the 2 Vulcan guns and the minigun is based on the Gatling principle.
Ready to fire! 1, 2, 3.
In the modern-day Gatling, the main moving parts are a rotating barrel cluster, a rotor, and a gun bolt for each barrel. The gun barrels are attached to the rotor and turn in unison. Each gun bolt is free to slide fore and aft on tracks in the rotor. Positioning of each bolt is determined by a cam follower, which moves within a cam path machined in the stationary outer housing. The cam path causes each bolt to ram, lock, fire, unlock, and extract its round. The smooth motion of the bolts as they follow the cam path, to a great extent, accounts for the high reliability of modern Gatling guns. All motion within the gun is smooth and continuous, resulting in low parts stress, as contrasted with the high velocities and stresses found in most single-barrel machine guns. The 20mm M61A1 and M197 fire electrically primed ammunition, while the 7.62mm minigun fires percussion primed ammunition. Also contributing to long gun life and high reliability is the fact that each barrel and bolt combination fire only once during each revolution of the gun. This means that the total number of rounds fired are divided equally among each of the gun barrels. The reliabilities of these gun systems on various aircraft are compared in this chart. The basic M61A1 gun has a 150,000 mean rounds between stoppages, MRBS, as compared to the specification requirement of 10,000 MRBS. The M197 has a 60,000 MRBS against a spec of 10,000 MRBS, and the minigun a 400,000 MRBS against a spec of 15,000 MRBS. The figures clearly demonstrate how dependable the Gatling principle really is. Overall, system reliabilities are also high, the UH-1N minigun Pintle being the most dependable, with a 78,000 MRBS versus a specification of 10,000 MRBS. These numbers can also be converted to a reliability factor which represents the probability of successfully firing a burst of 115 rounds without a stoppage. Here, too, Vulcan and minigun armament systems have consistently demonstrated high dependability, with reliability factors in all cases well over 98%.
Admiral Dahlgren told me he regarded this weapon the most effective implement of warfare invented during the war. On this point, I must agree with the Admiral. I found the mechanism simple and not likely to get out of order, but in such event it could be repaired on board ships. Spare pieces, as in musket locks, could be part of the outfit.
The Vulcan, lightweight Vulcan, and minigun are easily maintained weapons. Gun bolts and barrels can be removed for service without major gun disassembly, and often without removing the gun from its mount. The best-known Gatling of them all is the M61A1 Vulcan. Versions of this gun have been in the military inventory since 1955, making the Vulcan the most widely deployed gun system in the history of armament. The Vulcan and derivatives of it have found applications not only on high-speed aircraft, but also in gun pods, land-based towed and self-propelled air defense systems, and a shipboard air defense turret. The mainline attack aircraft for the Navy for almost 10 years, the carrier-based A-7E Corsair, entered combat service in Southeast Asia in May of 1970. It was in this conflict that the M61A1 Vulcan aboard the A-7E saw most of its combat duty. Available space within the Corsair's airframe dictated that the Vulcan gun be placed below and to the port side of the pilot, while the linkless ammunition storage drum was placed directly behind the pilot. Interconnecting the gun and ammunition storage drum are flexible ammunition shooting and a flexible drive shaft. The ammunition system holds 1,019 rounds of 20mm ammunition. The Vulcan armament system is driven by hydraulic power supplied by the aircraft and can fire at rates of either 4,000 or 6,000 shots per minute. The Vulcan aboard the A-7E has shown itself to be an effective and reliable weapon for the close-in support of ground forces. The F-14 Tomcat is the most advanced fighter aircraft ever to leave an aircraft carrier's deck. With a primary mission of fleet defense and secondary mission capabilities of ground attack of tactical targets, the Tomcat places unique demands on its armament system. In the F-14, the Vulcan gun and ammunition storage drum are located port of aircraft center and directly below the pilot. Gun and ammunition storage drum are essentially in line, minimizing drive shaft and flexible ammunition shooting lengths. The linkless ammunition storage system holds 676 20mm rounds. As with the A-7E, the F-14's Vulcan gun fires at rates of 4,000 to 6,000 shots per minute. Test firings at target drones and strafing passes on ground targets have confirmed the Vulcan's dependability and accuracy on the Tomcat. Presently under development, the McDonnell Douglas Northrop F-18 promises to be the most efficient and effective multi-mission strike fighter ever to serve the Navy and Marine Corps. A reconfiguration of essentially the same M61A1 Vulcan gun system as in the A-7E and F-14, the F-18 Vulcan system has the gun located on the vertical center line of the aircraft and directly in front of the pilot. The linkless ammunition storage system is directly below the gun. The current design approach in the F-18 will be with all gun system components joined to a pallet assembly. The pallet assembly will then in turn be mounted to the aircraft. These scenes are taken of the YF-17, a prototype aircraft from which the F-18 was derived. Major maintenance to any portion of the gun system will be accomplished by detaching the pallet assembly and subsequently lowering the entire weapon system out of the aircraft. Firing rates for the F-18 Vulcan will be 4,000 and 6,000 shots per minute. By using the M61A1 gun system, the F-18 is assured of combat-proven high rate of fire weaponry for missions through the year 2000. The linkless ammunition storage and feed systems used on the A-7, F-14, and F-18 function on the same basic principles. Ammunition is held radially within a cylindrically shaped drum and is able to slide on fixed drum partitions. Ammunition is forced forward along the drum partitions by the revolving motion of an inner helix. An exit unit inserts the rounds into a closed-loop conveyor. The conveyor transports the rounds to the gun and returns the spent cases to the drum's rear entrance unit. Spent cases are reinserted in the drum for downloading later. This system maintains positive control of all live and spent ammunition, thus increasing gun system reliability many times over linked systems. To provide effective ground support for these fighter aircraft, the United States Navy has recently procured a new linkless ammunition loading system called LALS. The LALS is designed to eliminate the use of links in aircraft loading and reduce aircraft turnaround time. It also provides RADHAZ protection and permits greater shipboard storage of bulk ammunition. The LALS uses a double-ended linkless feed drum similar to the Vulcan ammunition storage drum mounted on fighter aircraft. In operation, the LALS loads fresh ammunition in the aircraft at a rate of 400 rounds per minute, while at the same time returning spent cases and unfired rounds to the LALS drum. Similar in operation to the M61A1 Vulcan is the M197 Lightweight Vulcan, a 3-barrel 20mm lightweight version of the M61A1. The basic M197 Gatling weighs less than 150 pounds or 100 pounds less than the M61A1. It has firing rates from 750 to 1,500 shots per minute. These characteristics combined give this gun a number of important aircraft applications. The M197 Gatling is employed on the Marine Corps' AH-1J and T Cobra helicopters. Designed for flight operations in the forward battle area, the Cobra uses its M197 to suppress enemy fire and attack armed personnel and unarmored or lightly armored vehicles. In the AH-1J, the M197 gun is mounted in a high-performance electric turret and has a design firing rate of 750 shots per minute. The gun is driven by an electric motor. Ammunition is fed to the gun in linked form through flexible shooting attached to the ammunition storage container. The ammunition storage container holds 750 rounds of 20 millimeter ammunition and is a product of extensive testing and design improvements which have led to a reliable, simple, and lightweight design. Turret control is provided by a stabilized pantograph sight aimed by the ship's gunner. The 20 millimeter firepower provided by the M197 gives the Cobra the standoff range and reliability necessary to maneuver in the mid and high-intensity battlefield environment. Also equipped with an M197 lightweight Vulcan in a turreted application is the Marine Corps' YOV-10D night observation gunship. This research and development system is similar in design and operation to the AH-1J turret. On the YOV-10D, however, fire control is provided by a forward-looking infrared sight called FLIR. This is actual FLIR imagery as taken in night firing trials conducted at Patuxent River Naval Air Station, Maryland. Again and again, the turret-mounted M197 lightweight Vulcan demonstrated excellent firing accuracy and dependable operation. While turret uses are a natural for the lightweight M197, this weapon has also found applications in the Navy's new lightweight gun pod, designated the GPU-2A. Designed for light fixed-wing aircraft and helicopters, the GPU-2A offers a lightweight, self-contained, high rate of fire gun pod for such aircraft as the A-4, AH-1J, OV-10, and AV-8A. The GPU-2A is comprised of 4 sections. The forward fairing is an aerodynamic shell covering the barrels and lower portion of the gun. The gun support section forms the structural backbone of the gun pod. To this section, the M197 gun and ammunition conveyor are mounted. Also in this section are lugs for mounting the pod on a suitable aircraft rack. The ammunition storage drum holds 300 rounds of M50 series 20 millimeter ammunition in linkless form. The aft fairing of the GPU-2A houses the pod electrical controls and power supply. Loading of the ammunition storage drum is accomplished through the aft fairing. The GPU-2A is a fully self-sufficient system, requiring only a simple trigger signal from the carrying aircraft. Firing rates are selectable at either 750 or 1,500 shots per minute. A completely loaded GPU-2A weighs only 585 pounds, while the empty weight is 417 pounds. An empty GPU-2A is light enough to be installed on an aircraft without lifting equipment. The U.S. Navy has conducted comprehensive flight and evaluation testing on lightweight pods on the A-4. AH-1J, OV-10, and AV-8A. As a result of these firing tests, the GPU-2A demonstrated a very tight dispersion pattern and effective range of over 2,000 meters. Other aircraft having undergone flight evaluation are the A-7E, F-4, and A-37. The smallest Gatling gun in Navy Marine service is the 7.62 millimeter GAU-2BA. A small caliber derivative of the M61A1 Vulcan, the GAU-2BA, also known as the minigun, weighs only 35 pounds and is less than 30 inches long. The minigun fires percussion-primed ammunition at rates up to 6,000 shots per minute. The GAU-2BA can be found on 2 Marine Corps helicopters, on the AH-1G in a turret similar to the AH-1J turret, and on the UH-1N in a flexible pintle mount. Designated medevac, UH-1N helicopters equipped with minigun pintles have recently been deployed worldwide. These helicopters are designed to provide quick medical evacuation to wounded soldiers and airmen. The UH-1N minigun pintle system consists of the 7.62 millimeter minigun, a flexible pintle, a specially designed brass disposal system, feed shooting, and the ammunition storage system and control box. The ammunition storage system can accommodate up to 6,000 linked rounds. The minigun provides the defensive strength necessary to enable the UH-1N to enter hostile territory on rescue missions. With the 7.62 millimeter minigun, the inherent reliability of the Gatling mechanism reaches its highest point. Years of field use have shown the minigun reliability to be over 400,000 mean rounds between stoppages.
Admiral Dahlgren, I am told, has since given permission to the commanders of fleets and squadrons to order Gatling guns for their use. It is to this end that I write you, so that you may be ahead of other captains in your fleet in ordering this most destructive of weapons. I am your obedient servant, A.J. Malden, Lieutenant Commanding, United States Navy.
The Vulcan, lightweight Vulcan, and minigun. Versatile, reliable, effective. Based on design principles over 100 years old. Perfected with today's modern technologies for the present and future needs of the Navy and Marines.
Postscript. R.J. Gatling, the inventor of the gun, told me of a new Gatling he is working on, which will be able to fire at twice the rate of the gun I tested. This would be over 400 rounds per minute. Incredible. While I admire Mr. Gatling, I doubt if even he can design a weapon to fire at such a pace.